All right. I'm very excited.
Okay.
I'm very, very excited. I'm here with Mohamed. Is it Sai or C?
Psi.
Sai.
I mean, you can say psi, C. It's pronounced C in French, but you
Okay,
can say
Mohamed
psi.
C. Amazing, amazing. Mohamed, thank you so much. I know we just chatted a little bit before starting. Um, so a little bit as to why I liked you. So I've been following you on X, and the first thing that hit me with yourself is you're sort of duplicitous or dual-sided individual, which duplicitous sounds like a bad word. It has a negative connotation, but the way that I mean it is, I mean you have two sides to you, right? You have the mechanical engineering side, and then you have the programming side. And I like that. And I think it's not far fetched to say that you're not doing anything out of the ordinary, but I like that your approach is from software because not that I like software more. Actually, right now, like I was telling you, I'm more obsessed with hardware. We'll see how that changes, but
Yeah.
I'm of the belief as a normie, as a noob who knows nothing, but just where I'm at right now in my growth, I'm of the belief that we need to connect both whoever's doing or understands the engineering, the hardware engineering part of things with the software side. They need to understand both. And I was telling you as well, like when I implemented those AI agents, because I'm a knowledge worker and I'm in the
Yeah.
trenches, right? Like I'm doing this work. I was able to implement those agents much better than someone who's an expert at building agents, but not an expert at what I'm trying to do. So even though they did discovery and they spoke to me and other folks on the
Yeah.
team, they couldn't really translate what we were saying into what we need. Whereas when I was
Yeah.
working myself and exactly, obviously took testing and it took some tries, I was able to make it. So I say all this to say is that I really like the approach. Now I do want to first
Thank
start
you.
with what you're making and what you're building, but in my
Okay.
head, and I think I made this mistake earlier too, I keep
Okay.
thinking the wrong name. So yours is
All right.
WebCAD.
WebCAD. It is
Yeah,
WebCAD. WEBCAD.
I keep thinking OpenCAD. I don't know why. I don't know if it's because of
Oh, see,
open code,
well,
but
I can see why it's like open source. Like it's no, kind of.
kind of not really, not really. It's just my brain, but
Yeah.
WebCAD. So I
Yeah.
guess I know we were having a really fun conversation just before we started, and we can continue there if you want. But I kind of want to know a little bit
Yeah.
about your what you're building, and I think
Okay.
something else I was thinking about. Sorry, just because a lot of things are coming to me, but something else I was thinking about is some folks always say like they don't like these chats and these interviews because a lot of time they feel like advertisements and they feel like
Yeah.
which I feel like we
Like,
because we've got so many bad ads about stuff and bad products, advertisement has become a bad thing. But I think if we
yeah.
think about advertisement as, by the way, this isn't a paid advertisement, but I'm just talking about the concept of
Yeah.
advertisement. Because advertisement has become a way of tricking people and getting you to see something instead of like, hey, I'm
Mhm.
just trying to communicate something that I'm doing, something that I like, right?
Yeah.
And I
Just
think,
share the ideas, and
yeah,
whoever likes it.
yeah,
Whoever
I just
likes.
wanted to set that before I have you talk about webcam because I don't want anyone listening to think this is
Yeah.
some way of me trying to get you to speak about your product because that's what you want. That's not where this came at all. When I reached out to you, I told you like I want to talk about hardware stuff and you were
Yeah.
open to it.
Yeah, you did.
But yeah,
You
tell
did.
us what's the
Okay.
mission? Like, well, first before the mission, why
Okay.
do this? Why do we need
Why
webcam?
do this? That's a really good question. And the answer is because I was really bored one summer and I decided to build a drone. And so like and so this thing is like the skeleton. It's like kind of hard to see, but this thing
I
is like
see,
the
I see.
skeleton of that drone,
Okay,
right?
okay.
Like there's more circuitry upstairs, but and I was using and during that time I was using SolidWorks a ton, like every single day. Like every single day I would like pump out like 8 hours, 10 hours SolidWorks like constantly, right? And I got like really good at SolidWorks. But then I realized like SolidWorks keeps on crashing every single day. You think oh it's okay, and then boom it just crashes on you. Like just as you think you're gonna make it, it just pulls the plug from underneath you. And then I'm like CADing like 24/7, and I'm like trying to get this drone, and I like build a drone, and like I'm like hooking up the circuitry, like the ESCs, like the four ESCs, like the electronic speed controllers, and I'm like learning how to solder and like pretty bad at this stuff. Like engineering teaches you things. Like I'm like a mechanical engineer. Like an engineering degree like teaches you things, but doesn't like teach you like everything, like how to solder. Like surprisingly,
Okay.
it teaches you how to solder for like a second, and then that's
Okay.
like it. Then they leave you. But yeah, I was soldering up this PCB, and I was like soldering up like the motors, like A22 112s that you can get on AliExpress. I like for any like hardware engineer like loves AliExpress. Like that's like mecca. It's like mecca for like hardware engineers. But yeah, and I was like, and while I was making the drone, I was like, CAD software sucks these days. Like SolidWorks sucks. Fusion 360 doesn't have like FEA. Like a bunch of them don't have the things I need to like figure out if this drone gonna work. Because I had to go to SimScale to like do like fluids analysis to figure out like the lift over drag ratio, right? And I was like, surely you could do this like way easier, right? Like it doesn't have to be like this. And so I was
Sorry,
like,
that was really
how
funny.
hard?
It doesn't have to be like
Yeah.
this. Life doesn't have to be like this.
It doesn't have to be this hard, you know? Like I swear, like sometimes it's not easy. Sometimes like ads is like, why do you do this thing? It's like, oh, it really doesn't have to be this hard.
Okay.
But I asked myself like, okay, can I build a CAD software? And before building like, it wasn't my first time at building software, right? Because I had built software before previously, like a year ago, and it was like when the AIs were like new, but like I still kind of knew some coding, like some Python and like C++, but like very, very, very novice level. Like I'm like generally not that good at coding specifically, but I know how like numbers work. I know what like numbers look right in a certain sense, right? So I was doing like a PCB, it was like this PCB heat AI project that I was doing, and it was basically going to like like do like the formalize the how heat affects transiently, like over time in 3D space, right? And then just have like a KiCad parser to parse like a KiCad board, right? And you could just parse the KiCad board. You can get like the copper layouts for each, like say like the board sits like it's like there's four, and like you get the copper layouts and you get like where the components are and where their max wattages are, and you can figure out like how the heat conducts in that board, like and where the hot areas and where the cool areas, right? And so then you can make an enclosure around it to figure out like a good enclosure that lets the heat drift away and keeps the board cold, you know? And so like that I was doing on the side like a year ago, and it wasn't that great, honestly. Like it worked well-ish, but it didn't work that well. And because I was trying to like formalize it into like AI, so I was trying to like bridge the AI gap. Like I was trying to like just have the AI learn like all these formulas, and then just basically get put in the wattages and then be able to figure it out, right? Like that was a weird project. And then I decided, and then I did something else. I did like a what's it called? Yeah, I did like a different like heat AI, and then I did like Parallels, and it was like this knowledge graph that I was trying to do. It just like format knowledge and just format like understandings of like different works, different like engineering works and stuff. And then and then like the models got really good. And you see the exponential, like it gets steeper, right? And then like 4.5, like Opus like 4.5, Opus 4.0, like those guys start coming out, and then GPT 5.2, 5.3, and then like now I'm able to like build like, and then like 5 months ago I put together like Open Cascade, like which is a CAD kernel from these engineers in France. It's like amazing. It's amazing what they open source to humanity, I think. And Open Cascade, and like that was my first rendition of like WebCAD in general. And it was like making these simplistic blocks and shapes, right? You can make a block and you can like extend it into like a longer rectangle, right? And like it was very, very simple, very, very simple, right? and then I just kept on adding things. I kept on adding like sketch and sketchy. If you're familiar with CAD interfaces, sketching is where you basically place points in 2D space or in 3D space. In 2D space, that gets transitioned to 3D space. Then you can extrude. You can like push it out to make like a surface, and then you could like extrude another surface inside that surface to make a cut or do an extension from that. And so like those were the primitives of WebCAD. That's where it like started, and then I kept on adding like assembly. Like you could put different parts together. So it's just like, let's say you made one single part, let's say like an L bracket. You could put it together with like some other part that you wanted, like nuts or like bolts or whichever one you wanted. And then like FEA got added, which is finite element analysis, and that's where like it's basically K equals to FU, like F equals to K equals to FU, right? It sounds like saying FU, but I'm not saying FU.
What did you call me?
But so sorry, F equals to K times U, and so this would basically solve like the stress element, the stress, because each square has like 6 sides, right?
Yep.
And so you can solve the stress between like each of the sides. So there's 6 degrees of freedom, right? So you just solve between each of the sides, and then you can figure out how stresses transition through a material, right? So for example, you'd have some like cup or whatever, and then you'd basically split it into like tiny cubes, and then you'd like apply a force on top of it, and then apply a fixture at the bottom to hold it steady, and then like see how does that material react with applied force. And then I made a CFD. I made like computational fluid dynamics, and then you could like it integrates over the surface of the fluid, and you could figure out like your lift over drag ratio, and like it's like, and then thermal got added like to do like actual thermal like based on a solver. So I had to make all these like different solvers in WebCAD in order for it to like solve like accurately, and I had to like compare them to like known like national like databases for like how linear element solvers like actually function. And that was a process, really. But
I can imagine.
Yeah.
Now, are these so for someone like myself who's a bit of ignorant in CAD, because I think I do know enough CAD that there's a bunch of CADs out there. Are these things are these new items in the market? Like, are these not things that have already been explored in the past? Is that what WebCAD is doing, or is there something else that makes WebCAD? And also, I want to ask, the name WebCAD, with all the CADs out there, I'm surprised there wasn't WebCAD before you.
Oh no, right? Like,
it was like great.
Kind of hits me now. It kind of hits me now, but then I'm like, how is that possible? I don't know. Maybe it gets from God. But it's like how do they differ? How does like WebCAD differ from like Onshape? There's like 5 or 6 plus CADs we can list. We can list like Onshape, and then we can list like Fusion 360, and then we can list like SolidWorks and FreeCAD. There's FreeCAD. That's usable. And there's like another one that I'm missing, but there's like a bunch. And a lot of what these CAD softwares do is basically like it's kind of like drawing, but like when you get into assembly, then it becomes like tougher. Like making like the 3D solid isn't actually like the hard thing. It's like making the assembly. Like how do the parts fit together? What is a concentric mate? Like how is that done in the software, right? Like and is that like an actual concentric mate that you're doing, right? And like FreeCAD does have those things, but you have to download it, right? And like Onshape does have that, but you also have to download it. But then there's like the web version of it, but that's run off their like CPU clusters that they have, right? And then there's like Fusion 360, you have to download that. And then there's but like a lot of them you have to download, and the ones that you don't have to download, you don't have finite element analysis, so you can't actually do structural loads on it. You can't figure out what part breaks, what part doesn't, you know? And then and then like you add on to that, it's like okay, cool, okay, it has all these things. It has FEA, it has like assembly, it has sketch, it has what you need to make like items for CAD and stuff, right? But like what is it actually doing that's different? And it's like I think the best terminology for it would be like a platform for autonomous AI engineering and hardware design.
Nice.
Yeah. And I feel like because like a lot of them they like they're not really accessible, like, and also the cost. Remember, if you're looking for good CAD software, the cost of it is like pretty high. Like if you're looking at like very like high premium CAD software, it's like 5 to 15K yearly.
I did not know the prices were that high.
Yeah, I know it gets pretty high if you really want good stuff that constantly works.
So 2 questions. What do you have against downloading in that sense? Because you mentioned downloading as if it's a bad thing. Is it the running part?
Good.
It's hard to run. You need hardware like a compute. Like what's the difficulty with downloading? I say because I like download stuff. I hate web apps. I hate apps. Like I prefer for me to download stuff and have it on my computer or phone instead of having it go on the web. Why is your approach different?
It's the friction in using it. It's the friction in using it, right? It's like ultimately comes down to like the friction in using it and collaborating in like a place, right?
Okay.
It's like if I have to download it, right? That's friction. That's friction between me. Like you're already on the site. Like when you go to get a download, right? You're on the site, right? You're on the site already. That's like that's like another step, right? And it's like, what's the most seamless experience such that someone can engineer and then just like pause their work and then go back and keep engineering and keep making like hardware? It's like you just want to load it up on a browser. And if you want to send it to someone, right?
Yeah.
Later, like in the future, if you want to send your design to someone, you just send the link. You just send the link and then you just load it up and it pops up and the design's there. You can edit it right there.
Interesting. I like it. You seem to be going against what I think that the trend is, not with CAD, and I'm going to ask you this as well. Do you believe this? Because I think my brain's running in 100 directions, because we were speaking earlier before we started, when we first met, how everything is friction, right? And in the physical world compared to the software world, right? When you're trying to make something, you want to plan, but not plan too much, because it's friction. You want to try to minimize the friction to the optimal state. It seems like you've carried that philosophy in the webcam, which is really cool.
So time to decision. You want like is like you want time to decision to approach zero. Like you want decision to be like almost like immediate. Like you want your time to making the decision to not be there, to not be a factor of like actually doing the thing or not.
I love it.
Right?
You're taking it all the way. Do you feel that way about other systems? Like, for example, I don't know, YouTube. Like, would you rather have a YouTube app or YouTube on web? Like, I'm just curious to know, is that just for CAD that you feel this way, or is that something that Mohamed feels strongly about in his entire life?
I feel like if these are things that are structural, like if these are structural things to me, and like if I will use, like, I'm not saying WebCAD will never develop an app, right? I'm not saying like this is like out of scope, like we'll never have an app, because like in a sense, like because it runs so well on browser, it can run on an app even better. It can run like 10x better on an app, right? But it's like it's not that WebCAD will never have an app. It's like minimizing people's friction between them designing something that they want. Like that's how I think about it.
Simple, yeah.
Because like that's ultimately how I think about it. What was your question? Can you repeat your question?
I was just wondering, just for the web, because in my head I'm thinking WebCAD website, but that's not the case. I mean, right now that's where you're at, right? But in the future, it depends, which direction you go. Again, I was just playing off of the web, because I think it's a really neat name, because I wanted to also know, like, the web CAD, like, is there a play on words? Is it just a good word? Is it a marketing word?
It's also inspirational in a way, right? Because it's like the World Wide Web. Like how much has like the World Wide Web enabled for like humanity, right?
Absolutely.
Yeah, it's like and it's also like WebCAD itself is kind of itself a play on words, because
Yeah,
ultimately I'm not building a CAD like it's not like only computer aided design. This is like
right.
computer aided design and simulations, right? It's
Exactly.
like agentic like engineering for the AI can interface with you
Yeah,
on like in WebCAD, right? And
yeah.
just streams it,
I think
right?
if we were to like take the AI of CAD, I think web
Mhm.
is a closer word that would make sense, right? Like kind of like a spider web is what I'm thinking, right? And design and
Yeah,
you know connecting, right? So I think it's a very
yeah,
very very good choice. And then the
yeah.
next question is because kind of continuing with the question of like why, how's it different from other CADs, etc. You also mentioned that the price, right? The other CADs are very very expensive. Um,
Yeah, the overcut.
Sorry, go
It's
ahead.
because it's because I think that engineering is like a very democratizing thing, right? I think engineering in general is a very democratizing thing, and I think if you're able to provide like like if you're able to provide engineering at a very high quality level, like engineering tools at a very high quality level that people can use and people are like are like very very sure that this part will not break based on the math that was carried out by this platform, based on like our validation benchmarks that we'll post, right? It's like if we are certain made in this material, uh, in this certain shape that this thing will not break and that this thing will not like melt and whatnot, like we're so certain of this and and we want to go build that thing. And how do I build that thing? And that's and like where's the closest place I can build that thing on the web? And how can I build that thing without like people might not like in the first world might not think like we live in Canada, I
Yeah,
think, and and people in the first like I'm a dual citizen, I'm the American and Canadian citizen,
nice.
and
Love it.
people in the first world might not think about these things, let's say, of like designing like water pumps and like people being able to do them, but like people engineers actually do them, like the engineers
Yeah,
exist outside of like
yeah,
first world
yeah,
countries, you
yeah,
know. And people who can make things exist outside of first world
yeah.
countries, right?
Absolutely.
and and like I like look at and like it's kind of inspiring, like looking at like the users and like where they come from in like WebCAD, and you see like people from like all over. You see people from like Beirut, people
Oh
from
wow.
like people from like Cambodia, people from like Vietnam, people from like and like engineering firms and whatever. But like the thing is, it's like engineering is super democratic, right? And
Yeah,
it's like anyone can build in the physical world. Like the only limits, the only rules are the rules of physics,
yeah,
right? That's
yeah,
those are the only rules to play,
yeah,
right?
yeah.
And it's like how do you like broaden this so that and like more stuff being built is better, and a lot of these CAD interfaces like SolidWorks and CAD and like Fusion 360 and like Onshape and whatever, like SolidWorks is the only like serious guy, like the actual like serious player. But then there's like Cosmo, but that's like doing simulations, and those are guys that are like serious, but just in the simulation realm. And you want someone to have like a serious way to go about like benchmarks and validation, and like knowing that like what you're running on WebCAD is like accurate, it's like engineering level accurate, and you could like do your analytical like results and compare against it, and you know it's going to be like legitimate, and like being able to like engineer legitimate things. And I think that would like have more cool things in the world aside
These,
from having it under like a paywall. So
yeah,
yeah, that's it.
these individuals you mentioned. I don't know if you had a chance to speak with them or if you know, like in Beirut and Cambodia, etc. How did they find you? Because I always find that very interesting. How folks
Yeah.
find, really early made. Because this is like you won't be able to see this on a website, or you won't see this on a Google hit list. Like how would they find? Was this through X? Like how did they find it?
It's mainly like we put a bunch of posts on Reddit, but then we got banned. So
Oh no.
we have like that channel.
Okay.
So and also like ChatGPT recommends us to people, which is pretty cool.
Oh,
I don't know
nice.
how we did that. But, like ChatGPT recommends it. We just get a bunch of users from like ChatGPT.
Wait,
It's like
how do you know that? How do you know that ChatGPT recommends you?
because we see it from a database like
Oh,
refer
nice.
ChatGPT. ChatGPT.com. I guess they like searched up something like, okay, how do I build that thing?
That's
And
so
it's like,
sick.
how do I build this thing? And then it's like, okay, like what can I simulate it? Can I do to like make sure it works? And maybe they find it through there. That's just like my like guess at it, but
Yeah,
like
yeah,
maybe
yeah.
it's through
Do
some
you have
other.
any idea
So yeah, it's ChatGPT.
how ChatGPT would like how would you get on that? Like if you want to
I
design for
think
that.
well, whenever you click like a link on ChatGPT or some AI link, like it like does like the referral links, like
Yeah.
like
No,
the database knows
I
like
mean,
who's sending
if
it
you
over.
wanted to list on there, kind of like how you want to list
If you
on if you
like you
want to
wanted
show
to like
up,
list on it,
like how would you do that? I mean, I get it. You did it by
I
mistake, but
don't
that'd be
know.
cool to
Yeah,
understand. How does that
I,
happen?
I, I don't really know. We're just like odd people.
Sorry, unrelated, but yeah,
Yeah,
okay, so very
not
cool.
really
So from
sure.
ChatGPT,
Yeah,
that's
yeah,
crazy. The same tool that you
yeah.
made the tool, right? I'm assuming that you use either Codex or Opus or some kind of agentic
Yeah.
coder,
A
right?
mixture of like genuinely like all of them, really, but mainly Codex,
That's
right
so
now.
cool. The same system that helped you make it, the same system brings clients.
Yeah,
That's a
yeah.
great advertisement right there for at least in your scenario. Um, cool. Oh man, that's so cool. Having people. Are you saying that WebCAD is free? You don't charge anything for it?
No, we're not saying okay. We're saying like some things that are not on other people's CAD interfaces are free in WebCAD. Like finite element analysis, like we won't charge for that. Like we will never charge for that. Like sketching, assembly, we'll never charge for that. Like and yeah, we just won't charge. But the things like thermal and like computational fluid dynamics, like these are things that are like kind of hard to do.
Yeah,
I'd say it's kind of hard to do and
yeah.
like push out software on browser that can do that stuff. So those things will stay under subscription. But the things that like people like actually need like structural integrity and
Yep.
to check like whether something's gonna break or not, that should be anyone should be able to get that information by
That's very
WebCAD.
cool. That's very
Hopefully,
cool. Um,
yeah.
is there a team behind this, or are you just soloing it?
It's me, and I have
Nice,
a co-founder
beautiful,
that does like the growth and quality side of things. But yeah,
amazing.
I basically do all the technical work.
That's amazing. That's amazing. So I have a few questions that I sort of racked up as you were talking, and I'm trying to make it so that we don't disconnect from the current flow. But I really have to go back a little bit to you mentioned school, right? You said in university you learned
Yeah,
engineering, but you felt like you didn't
yeah,
learn what you were supposed to learn, or maybe what you would have learned, or maybe you can clarify exactly what you meant. But I'm curious to know, right? You went to school in Canada, right? I assume.
yeah. I went to school in Canada. I have a bachelor's in mechanical engineering, and I've worked in the field of mechanical engineering for.
So
I've worked in aluminum extrusion. I've worked in as a bike shop mechanic. Like I worked on many bikes, electrical and normal bikes, and I've worked on doing analytical calculations and like stuff for seismic to figure out like the seismic trends and to figure out things like the sortie signs won't fall on you as you're trying to leave buildings for like hospitals and stuff like that. So
it's very cool.
yeah,
So as someone
yeah,
who's gotten hands-on experience and practice, if you were the program director of the school you went to, you don't have to mention them. It's okay. But if you were the
okay.
program director, how would you design? What would you keep from what you did in school, and what would you add that you think would lead to you understanding better, you just being a better overall engineer and mechanical engineer at that?
Me being a better overcall
Because you
mechanical
mentioned
engineer. What would
soldering.
I add?
You mentioned soldering. You said that you didn't get much experience with soldering.
Yeah. I would just like add like I don't know like soldering classes I mean like mechanical engineering is great because you get to work with like a bunch of things like mills and like CNCs and like you get to work with like a bunch of things that you might not ordinarily be able to, right? So and like you build breadboards and circuits and like a circuit class and you program stuff, so you do get like a touch of everything, right? but I feel like soldering really wasn't in the picture. Funny enough,
Okay.
right? You'd think soldering would be like important, but yeah, I would just change that, and I would do like less. I don't know, less like an exam, like formatted test type thing, and just like more like physical, like figuring out problems. And then you're graded on like your result to that solution, to that actual problem space, like in a time duration. So I guess like, but the mechanical engineering is all about like analytical solutions, like pairing them with simulation results.
Right.
So it's like hard to like square that in a
Interesting.
way.
Like, do you think do you think just based on again, this is just a curious topic because I love school and I want to improve it. I do feel that our learning system is a bit outdated in the terms of that a lot of the focus is in like reading and mental
Yeah,
gymnastics, which are good. I'm not saying that it's not needed, but I wish, for
yeah,
example, kind of like what you said, instead of an exam, especially for things like mechanical engineering, instead of an exam, have you do a hackathon type of thing, right? And you
yeah,
pass if your solution
yeah,
works. If it doesn't work,
yeah.
then you don't pass.
Yeah, that would be cool. That would be cool. Then you get to like filter out people who don't like people who are like I don't know. I think that would be sick. I think that would be sick.
In a safe environment, right? With monitoring and supervising,
Yeah,
that'd be really
yeah,
cool.
yeah, yeah. But the issue that comes down to that is like funding and like it's
But we
like
pay
it
so much
all goes
money
down
for our
to like
schooling,
funding.
especially in
So
Canada. We pay so
I
much. Like,
know,
what
I
does that money
know.
go
You'd
to?
think, you'd
What does
think.
the money go
I
to?
know.
But anyways, I don't want to make it. I don't want to make it political or
Yeah.
budget. I'm just I just think like
It's all downstream. It's all downstream politics. I'm
because
joking.
so yeah, I don't know. I want to stay away
Yeah.
from that. But the reason why is because I'm actually looking into getting maybe like some classes, um, to do some hands-on stuff. Like I don't want to become an engineer. I want to say that right now. Like I don't have a desire to do that, but I want to
Okay.
go and play. Like I want to solder some stuff. I want to
Yeah.
like the just touch it. Like I want, but in a safe environment
Yeah.
because
Yeah.
there's a place in Toronto called Hack Lab. I don't know if you've heard of Hack Lab, and they have
I've
some
had.
of the. It's like a not for profit. They have like an open, what's the word? Open, like anyone can go on Tuesday. The word's not coming to me. Open house.
Okay. Open house.
Open house.
Yeah.
So everyone can go on a Tuesday. So and they have all these tools. But I'm scared to use them, and I'm like, hey, like, can I have someone who would know this, right? And I try to
Yeah.
go whenever, so because I'm scared to use it, and I don't want to break anything. Like these are expensive machines. Like I don't want to. I know I know how I am. I break stuff easily, so I don't want to.
Yeah.
But I'm looking for classes. Like I'm looking to see maybe like a college or whatever, just because I want to go and play in a safe environment. Just go and
Okay. Okay. So
like
you
burn
just
some
want to be able
stuff.
to like
I just,
you just want to be able to like use the tools, like just be able to, like fuck around, and use the
well,
tools, and
because
just not
so
like die somehow.
well, I want to learn. I want to learn, and I do want to
Yeah.
build stuff. But I'm just scared because, like, okay, and this is a personal thing. So I'll tell you a story. I hated basketball growing up. My entire friend
Okay.
group were basketball freaks. Like they loved it. I love 2K.
Yeah.
Like I love playing basketball on PlayStation, but I never enjoyed the sport. One because I was always a bit shorter. Like I had a late growth spurt, so I was always shorter. And also like I wasn't strong enough to like shoot threes. Like that takes a lot of
Yeah.
effort, especially if you don't know
Yeah.
the mechanics of shooting or whatever. And
Yeah.
during COVID, yeah, I would have been, how old was I? 20, 23, 24 during COVID. Um, there's nothing to do, and I had like this little space that my dad said, hey, you can use like as a home gym. It's like a little, like I guess it's like a shop, I guess, but it was empty. So I made like a gym there. I had like
Okay.
weightlifting bar, and I even installed a basketball net just
Nice.
indoors. And but the small version, like with a small ball, but a real like it's like hefty, but it's not the full size. So I started playing, and because now the ball was lighter, and also because there was no one there to judge me, right? It was just me playing around.
Yeah.
I started recording myself, started watching, techniques. I got really good. Like I got so good
Okay.
that the next time I played with a couple friends who know I don't like basketball and who know I'm terrible at basketball, they saw my technique and they're like, "Wait, what?" They're like, "Bro, where did you learn?"
Doing like behind the back. You're doing,
So
like,
I learned that. And by the way, one of my goals, I have some physical goals, which is funny, physical hardware, but I have some physical goals, and one of them is to be able to dunk on a 10 foot,
oh shit.
which is really
Oh,
hard
shit.
because I'm
How
5'9",
tall?
5'9", 5'10". I'm short.
5'9"? Okay.
Yeah,
Okay.
it's hard.
I'm like
I need
5'11".
I
I'm
need
like
like a-
5'11". Like I can like.
I need like a
touch the rim,
35,
like-
35-inch jump at least to even be able to like,
Yeah.
do one of those like touch dunks.
It's
But it's okay.
possible.
I'm gonna try.
possible, it's possible.
I'm gonna try. I'm
It's
gonna try. But what I mean is, for me and in the way that I learned, I need a very like specific environment. I need an environment where it's okay to make mistakes. I don't want any judgments, and I need to be safe. And that's
Okay.
why, because I'll show you something. I bought a soldering kit and stuff like that, like, cause
Oh shit!
but I'm
Let's
scared.
go.
I'm scared. I'm scared to do anything.
Go. Lead poisoning. Let's go.
Yeah, because I live in an apartment too, so there's no fans or whatever. So, anyways, I kind of forgot where we're at because I was just going off on a tangent. But schooling,
basketball
schooling,
goals, yeah.
basketball, schooling, and back to university. And I think because I love school so much, like the whole concept. I know there's like a movement of like we don't need school, and look,
Dude, I do not like school.
but I know, but why? Why? And I think the reason why is because
Why?
they don't let us do the fun stuff. For example,
Yeah.
I bet one thing you
Yeah.
really liked is the cool people you met. Imagine if you could do whatever you wanted with them during class, but like class related stuff, like mechanical engineering stuff. But imagine if you were given a bit of a free roam, free range, and you guys
Yeah.
could decide. Imagine if you build WebCAD back then in school with your friends. Like, would you not enjoy it more? The reason we don't enjoy it is because we're force fed a type, which again I think there's value to that type as well, but it's so focused on that. Like, here, just read this, just learn this,
Yeah.
come listen. I fall asleep. Like in my work meetings, like anything that goes more than 15 minutes of listening to one guy talking or one lady, like I'm like I can't pay attention. But when I'm the one talking and I'm participating, I'm in it.
Yeah.
Like I enjoy it.
Yeah.
Right. And it hurts me because like again I really believe in university and especially being around people of the same mindset and want to do the same thing as you, and
Yeah.
right, because that's the beauty of it, right? You meet all your cool friends and your forever friends. I'm not saying that I'm not saying anyone that didn't go to university or anything doesn't have great experiences. I'm not saying that at all. I'm just saying there's a lot of value, and I think if we change some things to it, it could be great again.
Yeah. I agree. I think the pursuit of knowledge is a noble cause. That's
Absolutely.
what I think.
Absolutely.
But I think that schools are these artificially constrained environments that just hamper down the soul, just beat at the soul until there's nothing left. So that's my view. But
I mean,
yeah,
how long have you been out of school for? Because I think that matters.
I just ended.
There you go.
It's like a
There
week
you go.
ago.
There you go.
Like 2 weeks ago.
There you go. That's why I asked, because it's natural, right? Like it's natural. I remember I didn't have a great time in high school. Like I didn't think high school was that great. And I had a pretty good high school. Like I wasn't bullied or anything like that, which I know a lot of folks
Yeah.
go through that, unfortunately. But I didn't see any value in it. Like I'm not doing, like I had seen all these movies when I was a kid of high school. And when I look at those movies now, those are 25-year-olds pretending to be high school kids, and they're doing all these cool stuff.
They're all playing off the nostalgia that you're doing.
These guys are like white hair in middle school, high school, and I'm like, that's how it's gonna be. It's gonna be so cool, but it wasn't like that. It was very
Yeah.
childish in a good way. And honestly,
Yeah.
I'm glad for it. I'm glad that I was
Yeah.
a kid. Like I look at kids today; they grow up very fast. And I don't envy that. I like that.
But to be fair, Canadian universities are different from like American ones. So it's like the university scene and like the student life scene is like different in terms of like American Canada. But
Are you talking about like the major ones, right? Because U.S. has a lot of universities that are not really universities.
yeah,
Right. Like
yeah,
they're kind of like technical schools, which I
Yeah.
guess would be like our colleges. But
Yes.
I think the big ones, they're kind of similar to the big ones. No, like if you were to take U of T or Waterloo and compare it to like Caltech.
yeah. Compared to the big ones, yes.
Yeah. Yeah. But I love the U.S. I love the U.S. and I love the U.S. I know it's not a popular thing to say right now. But
Dude, it isn't for
I-
some people. Dude, a lot
I
of
love
people
both.
got it, isn't it?
I love both. Like,
It
don't
is.
ask me to
That's what it
choose.
is.
Don't
That's
ask me
what
to
it
choose.
Go USA, go Canada.
I love both. But anyways, let's stay away from that talk. So there were a few other things that you were
Yeah.
mentioning. So you mentioned open source.
Yeah.
I wanna get your definition, because I feel like open source is a very loosely
Totally.
very, very very loosely used term. I want to get your definition to it, and I want to get your like, why do we need open source? And not from the perspective, I understand that we need, because okay, let's give access to people. But what I mean by why do we
Mhm.
need it is, I find that you worked so hard on this thing, right? You put your soul and your spirit and your blood into this thing, and now you make it open source. How do you commoditize that? And again, I know commoditized is a bad word, but for me, I believe in that everyone should get rewarded for their effort.
Yeah.
So how does Mohammed get rewarded for doing such a great thing? Because if you make it open source, I don't know how you benefit. Maybe it's my ignorance, so
Well,
educate me on
well,
that.
my like, I'm gonna be honest. Like, WebCAD is not open source. Like, it does not do like we like our goal is not to like open source things, but it's to be like having it on browser and being accessible via like one click away.
Right.
Like that's ultimately like where you like accessibility,
Right,
right?
right.
Accessibility. Yeah, I don't like. I think we're gonna open source parts of it. Like I think, like I've been working on this tetrahedral mesher, and if you know anything about tetrahedral meshers, they're like 30-year like PhD works. But I'm trying to like make mine right now, and
That's ambitious. That's what someone
yeah,
said. Very ambitious.
yeah, and so yeah, I'm trying to make a tetrahedral mesher, and then I'm gonna open source that part of it. But like I don't think WebCAD as a whole is gonna be open source, but I think the tetrahedral mesher, which is very hard to do, I think I'm gonna open source that with like validation benchmarks. So I think that would be cool. So then people can like play around with like something that can do like static stress solving, like linear static stress solving, like on CPU,
Nice.
like on browser, whatever. That'd be cool.
Beautiful.
But yeah, open source is great and it's amazing because how many of the world's like infrastructure, like software infrastructure is like built off open source, like so much, like where would we be without it today?
Right.
Yeah, which yeah, I think
Which sucks. I hate that open sourcing contributes so much to the world, but not to the person.
Yeah.
To the person who makes it. It's like, why is it like that? It feels unfair.
But it depends on your view of like contribution, right? Because some people might view the monetary reward as like the contribution, but some people might view like just like the recognition as a contribution, right? Because in a, like the Linux found like is it Linux? Yeah.
Yeah.
They got like
yeah, he's cool.
Did they have any monetary contribution for that? Like in some sense, kind of, not really.
I have no idea.
But
I have no idea. Like Apple runs on Linux, no?
Yeah, I think so.
They have to pay for that. I mean, I don't know. Actually, I don't know.
You see what I mean? Like it's those, but they get like a lot of the credit in some sense.
I hope he does. Like I think Linux, and I haven't used it, but just using Apple, which is based on it, and I think now there's like at least what I've seen, there's like a trend of electronics engineers like using like Linux PCs because they're so, I don't know, dependable, or I'm not sure, or I'm not actually sure the reason why they're using it, but I know from the fact that Apple with these great products that they're making with the MacBooks, and they run on Linux, like that's so cool. Like, and I think it's like, I don't know how many, like I know Linus, I saw an interview of him recently. Mm-hmm. I thought he said he's like the only employee. I'm not sure if I'm wrong on that. Like,
okay, it says Apple does not use Linux.
Oh my god, where did I get that from?
Yeah. Mac OS is based on Darwin, which uses XNU kernel.
Okay, well.
Which is BSD.
I have been saying this for a while now.
Some people.
So I've been lying.
I don't know. It seems some people get that confused with Unix. Well, okay. Is it? Everyone knows Mac OS is. It is Linux based. Sorry, it is.
I thought I've been lying this entire
time. I was like reading it wrong. I was like reading Unix.
Yeah. I mean, look, it's just because I'm a huge believer in giving credit. Like I'm the credit guy. In all of my personal, whether it's professional life or personal life dealings, where someone's contributed to something, or to me, even in my own growth. I know, like two of the co-founders of the organization that I'm a part of, Next Gen Professionals. Like these two, it's a lady and a gentleman. Like they've given me so much, like built me up, and it's hard to quantify. But any chance I get, like I give props to them. Like whether I'm getting some kind of recognition, I'm like, yeah, they showed me how to do this, and I try to quantify that, because I find that one of the biggest tragedies is when people don't get the credit or what's due to them, and maybe this is a bit of a personal thing, because I've seen it with my parents, doing a lot of great stuff, and while they didn't really need much in terms of wealth, because that part they had figured out, I did notice that they didn't get recognition for doing things that like are great things, but we don't notice them because we don't know.
Yeah.
And that's why like I'm always
Yeah.
like we got to give recognition to everyone, and whether
Yeah.
it's you know like moral or saying it, or if it's monetary, I think everyone should get the recognition that they deserve. And I think
Yeah.
because I'm the type of person that like I request recognition, like whether it's at my work or even with you or like anyone that I'm with, I'm like, hey man, remember I helped you one time, and not in terms of reminding you, like I'm not the guy who reminds you when I helped you, but I think it's important that I point
I
out
think it's
the
good.
value that I give and the value that even with my friend, my fiance too, like I tell her all the time like the great stuff that she does for me, but also like hey, don't forget to value me, because I do think we tend to like forget the importance of people in our lives.
Yeah.
We take it for granted, right? Like we're like, oh, don't worry, I have Mohammed. Like he's my friend. Like he can do this. He can
Yeah.
help me with CAD. He'll
Yeah.
just do this quick thing for me, but he doesn't have to. Like he might not have time
Yeah.
to do this, or like I think we have so many great resources around us that if we don't constantly remind ourselves with this like like recognition thing that I do, I find that I forget, and I have done that in the past, and so it's a
Yeah.
lesson that I kind of have to constantly. And again, I'll take the chance that by the way by thanking you for giving me the time of day as well with this chat and responding to my DM, because you didn't have to, and I'm learning a lot like right now, like all the things you're like you mentioned a few acronyms that I'm like, oh, is that what that means? I've seen that before, but I never really bothered to look it up because it seemed confusing, and but you spelled it out for me, like, oh, it's cool. Like these are things that I think we need to value. But enough sappy talk.
Yeah.
Let's get back to the meat of the matter here. You mentioned co-founder. I'd love
Yeah.
to know why. For me,
Why?
I don't believe in co-founders, and I'll tell you why. I love people.
Okay.
I work with people. I am going to
Yes.
continue working with people. I
Mhm.
just find that there's so like people's lives are so busy and so dynamic and changing that you'll never be on the same wavelength as someone for too long.
Okay.
And
Yeah.
again, this might be my experience. This might be me being a paranoid person. This might be I want to find a way for myself to never have to need a co-founder because of. And again, I've never had a
Okay.
co-founder, so I don't know if it's a bad thing or
Okay.
not. It's just
So
a perceived idea. So
I
I want to know how you thought
I
about that.
think about this as like a multiplier. Like if your strong suits are very very like if like you and your co-founder's strong suits are very like good, and like they match, they're really comparable with each other. Like I feel like it's a multiplier on the things you're able to achieve
Okay.
as like a force, right? Because if like all two vectors are pointing in the same place, and like you can multiply the magnitudes, like you can like do a lot with someone that can like understands like where the vision of this thing's going, like what we actually want from this thing, and like how the next couple months are gonna go by. Like I think that's important. I view like, and especially if it's some person that you know exactly how they're gonna react in every single moment.
Yeah.
Like because if you've known for like 10 plus years, like I've known my co-founder for like 10 plus
Nice.
years,
Nice.
and I'm not that old.
Yeah,
As you can tell.
those are important 10 years. Very
Yeah.
important years. Very formative 10 years.
Yeah. Like so I've like known him through like spick and span, right? And like I know how he's gonna react in certain situations, and I know, and he knows how I'm gonna react in certain situations, right? And that's like a multiplier, right? And like that's less knowledge that needs to be transmitted between the two people,
Yeah.
right?
Beautiful.
And that's the
Beautiful.
multiplier.
And again, forgive me. I don't mean to insinuate anything, but because I do know with a lot of co-founders that I've found, like some of them don't have agreements in terms of like pen to paper or like contracts. Again,
Yeah.
feel free to decline to answer. I don't wanna ask anything that's too personal, but is that something that you've approached differently? Have you guys sort of put out contracts, or is there like some kind of gentleman's understanding that as things ramp up?
I mean, the first time you ever greet your co-founder, I feel like it's a gentleman's understanding, and then you shake on it, and then you look them in the eye, and then you say like, okay, we're gonna do this.
Perfect.
And like that's how that went, and that's how it is.
Beautiful. And that's really awesome. Like we need trust, right? Like if things get too I don't trust it, then you got to think about the relationship there. So you're at with WebCAD now in 1 year, right? If we were to talk again in May of 2027, what do you want to see WebCAD be or at, right? So is it going to transform into something else, or do you want it to go with the current mission, but it's a different level in terms of scale?
So WebCAD's goal is spans from actuators to humanoids to rockets. That's WebCAD's goal. So
Okay.
first we get everything, we get all the internal components, all the internal infrastructure to build out an actuator, and then we have you be able to build like a robot, a humanoid robot, and then we're gonna aim for a rocket ship. And because WebCAD scales based on how intelligent the models get, and I think the models will get very, very intelligent
Nice.
very, very soon. I think in a year's time, we have some kid in some part of the world that we may not know the name of design and build a rocket that goes out of orbit. That's what I think. That's what I think WebCAD does.
In 1 year?
Yeah?
In 1 year?
In 1 year. In 1 year.
That's sick. I
That's
love
the
it.
goal. That's the goal.
So is WebCAD going to remain a software company, or do you see it expand? Like you design it, right?
Yes.
Can WebCAD make it, or do you want to leave that to other competitors?
I think I like WebCAD is going to be in the game of building things. I think because it's like building things is like how you actually like figure out if your assumptions, your like standard assumptions about
Yep.
like your computations are like accurate, right? And like you have to build things in the real world. So like we might not build out like all the actuators and all the humanoid robots, but we'll build out like an actuator to test like how accurate our solver is, right? For torque conversion, right?
Yeah.
We'll like test these things out because we have to test out how good like what the solvers are, the simulation infrastructure is, because that's the basis for which the rest of the things are going to be built if people are going to build those things on them. So we're going to have to, in a sense, build those things in order to verify that they can be built using the software.
Yeah.
Yeah.
Okay.
But it's probably like a subsidiary or something. Maybe it's not
because
as big a company.
I'm trying to get to what I want you to do, right? I don't care what you want to do. Here's what I want you to do. I want you to manufacture. I want you to make stuff. I want you to take that knowledge, right, in software and what you're designing, and then take your mechanical engineering, foundation, and actually bring that to life. And I think that's what I want to see. That's what I think we need in Canada and in North America, and I think in the whole world. But I think we lack that here in Canada for sure, and we lack it in North America. But I don't know why we lack it. And maybe that's a question for you. Why does North America lack manufacturing of again,
Why does
specific
North America lack manufacturing? That's a good question. It's I think it may be downstream of a crisis of manufacturing knowledge that's lost. I think it's like downstream of like the fact that a lot of these guys that like do these like die casting things have like died off, right? And like a lot of them are on they're like 50 years old. They're still working on the same plant they've worked in for the past 35 years, right? And like a lot of that knowledge is like kind of just like hard to get to, right? It's like really hard to get to, and like and like die casting is like where everything else is like based upon, right? That's what in my view, right? And like a lot of this knowledge is like it's like very hard, very easy to lose, right? Because like people's lives are like finite, and they're like it's very easy to lose this knowledge, right? And yeah, and because like of course the idea of like exporting like all our jobs to China, and that also plays like a massive part in it, right? But yeah, I think it's ultimately because it's also like after being so predominant in software, we've kind of like lost touch from manufacturing, right? Because in the past 25 years, it's been dominated by software growth. It's been like the GDP has been dominated by software growth. Like all the like top Fortune 500 companies, software. Like a lot of them are software, at least.
Even today, right? Like AI.
Yeah.
I mean, NVIDIA is the only one that's not software, but it's being powered by software, right?
Yeah.
So question back to school for you. Why did you choose mechanical engineering and not computer science?
Because I mean, like I actually didn't like coding at first. I'm not gonna lie to you.
Okay.
like 5 years ago, if you told me I'd be coding like every single day, I'd tell you like there's no fucking chance in hell. I'd
Why?
tell you like this zero.
Why?
Like why? Because I just didn't like the fact that you'd have to like go on like sit at the desk and go into like human logic mode. Like it's fun. It's ironic I'm saying this is like someone that does
Yeah, look at you now.
like yeah. It's also ironic I say that as someone who's done like fourth level calculus, right? But,
Right,
like
right, right.
it's like it's like you're just like sitting there, you're putting like logic into like the machine. It's kind of like boring. It's like Excel. It feels like Excel work.
Yeah.
It's in some weird way. It feels like Excel work, right?
It's all Excel
And
work.
so yeah,
It's all Excel work.
yeah, it's all Excel work all the way down, right? And yeah, in some sense, I didn't like it like that. And also, my dad's like a PhD in mechanical engineering, so
Oh,
like
okay.
I'm
I
like
like that.
super into like all my brothers are in mechanical engineering. Like
Oh, that's a
one's in
beautiful
civil
story.
engineering, one's in civil engineering, one's in mechanical engineering.
I love it.
Yeah, another one finished mechanical engineering. But yeah, it's like just like a lot of mechanical engineering. I like objects. I like objects. But I also figured out that software is just like you can do a lot of fucking things with software, and that's why I went into software. That's why I do software now. I guess that's
So,
if that answers your question.
are you retired from ever going to
Am I
full-on
retired?
mechanical
What?
engineering?
What? Why would I retire? Why would I retire from doing the atoms? Why would I retire? Never retire
Never?
from doing the atoms. Never,
Okay.
never. RubCAD's gonna build actuators, then humanoids, then rockets.
So how much of your
That's gonna-
time goes into actually building the software of WebCAD in terms of like testing it with actually making stuff?
That's a good question. So, well, technically speaking, like the FEA is based like I can only do like a couple like I'd have to add anisotropic materials because fundamentally like PLA, like polyethylene, is like the things for 3D printers are like I can't do that because it's layer by layer. I can't do that in like the FEA like
Right.
mesher that I made, right? So I'd have to like do something a bit different in order to solve that class of materials in order to test it out in the real world, or I'd have to actually order a part and then like test it. But then that I'd be using like their aluminum like 6061, right? Like it'd be like weird in that sense of like testing it out. But we're in talks with some people, and I think what we're gonna have in the future is gonna be super interesting, like die casting. Let's say,
Okay.
let's just say it has something to do with die casting simulation.
Okay. Without probing too much into that, in terms
Yeah.
of 3D printers, do you think that this project like this direction we're headed in with 3D printers, right? We said like it's with layers and it's with the filament. Do you think that that's we're just gonna get that better, or is it gonna be a 3D printer where like think like sci-fi where it just zaps stuff and it makes things
This is what's
like
so
I
hard.
wonder what you think about that.
This is what's so hard about software. What's so hard about hardware? Sorry, it's like trying to predict what things and like what scientific like objects are going to be available for humans to use in the next like years or so. Like I mean, you think about to like how the Jetsons portrayed the future, right?
Yeah,
It's like
yeah,
it's like
yeah.
kind of ridiculous, right? Well, like it's like in the same sense, it's true. It's like kind of hard to predict, right? It's like I like maybe it like zaps it, and maybe you're using like some weird like silica, and you're like and you're like doing a laser etch across it, and it's like growing from like the top down somehow, and like you could make the case for that would be like the next wave because you could do so many more materials with it, right? But and then there's like fused deposition modeling, like you just like zap a bunch of like chunks of like metal dust, and then it forms this like solid thing that you can use, right? There's like a bunch of these different things, and I think some solutions work good for some things and some solutions work better for other things, right?
Yeah.
Like if you're prototyping something that like you didn't care about the structural integrity of, like you weren't going to sit on, for instance, right? It's just going to sit on your desk somewhere. 3D print it, go
Right.
for it. 3D print it, go
Right.
now. Like who cares? But if you're doing something like you're doing like a metal part for like some like airplane or something, I mean, maybe like fused deposition modeling is like actually the better choice, you know. It's like, and then maybe for like dentures or something, or for like accurate teeth looking things, you could do like silica, like silicon. You know, it's like it's very hard to tell what exactly is going to be like the predominant usage of the thing. Like you can only extrapolate from past trends, and
Yeah.
what past trends suggest is like 3D printers, like the Bamboo A1, like the Ender, like these things are going to be cheaper and cheaper, and they're going to be faster and faster, and people are going to be able to make more and more complicated things and put them together. And like, how does what's the fastest way between them having that item and them doing the thing that they want to do? And
Right.
that's the software aspect, and that's
Would
like what CAD.
would you see any future in technology that maybe doesn't 3D print but 3D sculpts? Like, what if you put the actual um, material that you want, and it'll sculpt it for you? Is that difficult to do, or is that a thing that exists, or like how would you think that how do you think about things like that?
Um, like
Like,
I think
what if
so.
you put a silicon wafer, right? Like I have one here because
Yeah.
I'm all about semiconductors. Like I have this crazy dream of, the same thing you mentioned, democratizing, that's what engineering does. And I'm not an engineer, but what I think that would be really cool is, what if I could take this thing, put it into a 3D
Yeah.
printer or sculptor, whatever, and you know, it made me 5 nanometer, semiconductor that I can then plug into
That
whatever
you
I
could
need.
then put into your thing. I think that's possible. Like the laws of physics don't
Right.
deny Lurio from doing that.
Yeah.
Like Lurio Nelly is
Yeah,
able
but
to
the
do.
laws of sanity do. But
The
I'm
laws
just
of sanity say I don't know.
but I'm just thinking, what if instead of 3D printing, we instead do 3D
Yeah.
removal or sculpting? I don't know what word to think.
3D sculpt. There's like there's something else, because I was stating it was like fused deposition modeling, but that's like a little bit different from the thing that I was trying to talk about. It was the it was where they like zap. It's where
Yeah,
they like zap the metal, and
yeah,
like you just have a bunch of metal dust like in a block.
yeah,
You're basically like zapping all the layers from the bottom up.
yeah,
You're making a thing. I guess that's kind of like what you're
yeah,
hinting at. I think.
yeah. I think
Yeah,
so.
that's like out there. That's like out there. I forgot the name for it, but that's like out there. Like people have
Yeah.
that, but that's like costs like that costs so much, right? It costs like 80,000 USD, like stuff like
Yeah.
that. Like so, like people can't make these things, and why they can't make these things is because like the people that want to make them will eat. They're not enough. There aren't enough of them, right?
Yeah.
And the ones that can.
But
do it,
that's why I love where you're at with WebCat, right? You're trying to make something accessible, and like that. There's beauty in that. And again, it goes back to that same thought that we started democratizing. Um, a thought experiment for you, and I've asked this to a lot of folks, but I'd love to take your thought on it. Um,
Yeah.
how will quantum computing impact CAD and maybe WebCAD, and how will it impact mechanical engineering in any way you think, or it's not, it's a gimmick?
Um, I think I think there's a way for it to impact it. Like in like if it's just way easier to just solve for like simulations, right? To solve for like computational artifacts of what you want. Like I'm sure quantum can speed up these things, and then maybe you could have like some like topology that's like constantly evolving, like based on like your design, because you can attack the simulation so many times with it. Like that would be cool. That would be interesting. And I'm sure there's like other things that I'm probably not thinking of that has some weird effect on. But I think it'll I don't think it'll be a negative in development for engineering in general. That's what I think it'll be positive.
But
More positive.
you don't seem very excited about it. Is it because you don't think there's any value, or it's
Well,
too far away?
it's quantum is just too difficult. It's too like it's like you have to keep it in this pristine environment, right? And we can't make more than like a couple quantum computers a year, right? Like these are very very difficult things to make, and like scaling up the economy of like producing these things, and like having them in like a place, and like having them mass produced and like be usable
Let's put them in
like
Yellowknife.
like
Let's put them in Yellowknife somewhere.
we could do that, but I mean maybe I don't know much about quantum computers to like have a really good idea about this. I think
No, and
like I
that's
took like like a course or two, but like that's about it.
No, no, but that's why I asked, because I think they're very cool. I'm just like I don't know, what like what value we would see from them. I mean, it's my ignorance for sure, as I haven't researched into it too deeply. There was a question that we had before, which we left for this, but I don't remember. It's escaped me. Do you remember it?
The question that you had that you left for right now. Let me think.
I wanted it to be the closing question, but my memory
Closing question.
betrayed me.
I don't know. Sorry.
It was something relating to hardware.
The hardware.
And how you see the relationship between hardware and software, because again, I think you embody it really well. You embody the understanding of hardware, and I think the line of work you've chosen is very like directly translatable, right, from software and hardware and back and forth, right? The relationship, you can't. Whereas I feel like with things like, let's say, someone working on PCB design, right, or assembly or whatever, compared to someone making, making an app for, I don't know, hearing device, like, I don't know what would be the benefit of knowing both, right? What would be the benefit of knowing how to code a system like that, whether it's agentic coding or, coding it by hand, and knowing how to assemble a PCB or design a PCB? What would be the value there, right? Yes, there's some kind of, better compute. The PCB is a better design, but do you really need to know that? Do you really need to know that to also make good software?
To make good software about a certain thing, like I think it's like a.
Like
I think
thinking cars.
Work.
Like think about
Pardon?
cars. Think about cars. People who build their own cars, and they build them for a very specific purpose, whether it's racing, whether it's going off roading, and they change it. Do you think that that's the relationship we're gonna have with hardware and software moving forward? Now that software is so much easier to make.
I think designing and making stuff is like a flywheel. It's like a loop, right? And you're trying to make and like once you make something, right, you're kind of trying to like making the actual thing is like closing the loop once, right?
Right.
What you want to do is like make sure the loop's like spinning as fast as possible, and that's like your thing being as good as possible, right? Your object thing that you're making being as good as possible, right? It's like, how do you close that loop, that flywheel, so that it spins in like very shorter timelines, right? And that's where software comes in the mix, right? Like hardware is like the finite. You know exactly how long it'll take to get that thing, and you know how long it'll take to build. You know exactly how long, right? Like the software can like speed up that loop, right? Speed up that flywheel. And so like it's kind of like, I mean, it all goes back to WebCAD. I think like personally, it's like how do you like speed up this flywheel? Because when you make a car, like, you're not making one version of a car and then you're like, okay, we'll never make this ever again. This stays in the parking garage and this just never gets made again. It's like, no, sometimes it's like we improve it, make a 2012 version, 2013 version, 2014 version, right? And like that's essentially how hardware is, because you are solving the problem, right? But the problem statement always grows the longer you look at it. Like the problem statement you're trying to solve always grows the longer you look at it in the physical space. Whenever you're making something physical that interacts with the physical world.
That's
right?
poetic. That's poetic.
Yeah.
I have a lot more questions, but I know we're nearing the hour here, and I kind of want to save some of our talk for a year from now when WebCAD is at that crazy level you outlined. So the last question I wanna end it with, and again, let me know if you're not comfortable with this. We can go for another one, but I wanna know what's the one thing your dad taught you about mechanical engineering that kind of stays with you.
Always question your assumptions. Always question your assumptions. Either your model of the thing is incorrect, or the thing, you're not looking at the thing properly. Like it's like one of the two.
I feel like you probably ran into that lesson multiple times.
Yeah.
From your face. That's awesome. That's awesome. I really find, like, I know it's all about anyone can be anything in this world, but I just find when and maybe this is a bit of a wound I have with my dad. So my dad and my mom are pharmacists, and they wanted me to go in that field. But I just told them from when I was very young, like, and I was okay at school, but I told him like it's not for me. Like I have no passion in it. And I grew up in a pharmacy. Like I used to do all the Excel stuff for them, which is why I work with Excel today, because I grew up doing, all their Excel balancing and all the different drugs and medicine and organizing and running their computer stuff. But it just wasn't for me. Like I didn't find passion in it. And he really like,
Yeah.
I know he wanted me to be a pharmacist. He never pushed it on me, but I see value when children continue their parents' work, because it's like it's so like for me, like my fiance shocked them sometimes whenever she's sick. I'm like, oh, where does it hurt? Is it here? Is it on the left? And is it 2 inches below the belly button? Okay, here's what you take. Here's what you do. Here's how you treat it. I don't know why I know this, but I grew up with my parents, telling me this stuff. So I'm just
So,
kind of repeating back. And I think there's value when children of parents of the same kind of profession continue, because I think you penetrate so deep. And
yeah.
I think you can't buy that, as great as smart as you might be. And I'm sure there are people out there who break all the rules, right? But in general, I think when I love it. It's such a good story for me when I hear kids of
I mean,
parents go in the
I
same
mean,
profession.
yeah, I think it just like helps. I think it helps a lot. I mean, like it's like I've been in 100+ different like factories, like
Oh, I'm so
hospitals. Like,
jealous.
I've been in like a ridiculous amount of places
I'm
that
so
they build
jealous.
things
I'm
in, right?
jealous.
And like in some sense, I've always loved humanoid robots, right? When I was like 10, like even before like even knew kind of what mechanical engineering was, like I like humanoid robots, right? Because like why do I have to do all my fucking chores? Like I have someone else do it. Like, it's really that simple. It's
Hey,
always that
those
simple.
vacuums, the Roombas or whatever, I've heard they're very great
Yeah,
value. So.
apparently I've heard that too. I heard that too. But yeah, but yeah, yeah. It's just I mean I think it's super useful having like a person that's in like a field that you actually like. And, like you can just learn so much off them. It's crazy.
I know, I
Yeah,
know. And it's by osmosis too, right? Like you're not really trying to learn anything. You're just around
yeah.
them growing up, and it's like the knowledge is just there. It's a beautiful thing. Well, tell your dad. I say thank you for that principle. I'm definitely gonna do that the next coming days. I need to, question my assumptions.
Yeah.
And it's definitely a good life motto as well. Mohammed, I want to thank you so much for your time. Thank you again for the consideration. This was an amazing chat. I've definitely learned a lot. I need to go take a break because my brain is mush now from all that knowledge you threw at me. I wish you and WebCAD, the best of luck. I'm gonna keep following
Thank
you
you.
and seeing your journey, and
Likewise.
more power to you, sir.
Thank you. Thank you.